Well, thanks to Fiona for inviting me to this session. So I'm an earth scientist and a data manager in some way as well. I'm leading a data facility that's funded by the U.S. National Science Foundation for Earth Science Data. And so that's my contribution to this session and giving you a perspective of what we're trying to do, how we're trying to link up with the publishing world, ensure access to data and so on. And I'm going to try, just listening to Fiona's talk, I'm going to try to link up with what she said as much as I can to give it more of an integrated picture. Just starting off reminding us why we really care about research data so much. And it's, I've actually added at the bottom here the very recent new age data publication policy of the American Geophysical Union that actually emphasizes these two major reasons why we care, because data can advance scientific discovery and data is necessary to make science transparent and trustworthy. And what we need for that is, in order to advance scientific discovery, we need to make the data fit for reuse. And that's sort of the important aspect that I'm bringing into this. And this is just to underline sort of the saying, how important the open access to data has become with all these initiatives, directives of federal governments, of funding agencies, and so on. So, fitness for reuse of data, what does that mean? It means the data needs to be found, it needs to be discoverable, it needs to be openly accessible, it needs to be safe, in a safe place. But what is most important for me is it must be useful. What good is data if you can discover it but you can't really work with it because it's not meaningful? And the sort of aspects that researchers bring into the data picture is they know when they try to access data and work with the data what are the major challenges. And here in the US, we currently have a big initiative going on called EarthCube to build cyber infrastructure for the geosciences, and we had a number of workshops from different domains within the earth sciences, and these brought up common concerns of researchers, common requirements, and so I've just picked out two of those. One that is clearly at the top is the concern about data quality. Can I trust the data when I use it for my research and so on? And there's a whole list of aspects that I'm not going to really go into much further, but you can talk to researchers directly and they give you some indication of what they mean. Can I really trust what they give me as uncertainty? How far do I need to dig into the data actually to make sense of it? And how complete is it with respect to documentation? Ultimately, it's knowing that I can trust the numbers is what researchers care about. And that relates very closely to the level of data documentation. And that's a big problem at the moment, that there is inadequate documentation of the data, lack of context, lack of information on the data provenance, a lot of data generated on samples, for example, that are collected out in the field. There is not enough information where they were collected, how they were collected, and things like that really impact the reusability of the data. So what we need is complete documentation. We need guidelines for the investigators to properly include these provenance metadata, and we need a review process, and clearly Fiona has talked about that already, somebody who looks into these data sets and checks if metadata are complete, if there is enough information. The other aspect of utility of data is it becomes much more useful to researchers if it is deeply integrated. within a discipline or across disciplines, if it can be integrated across disciplines, and that means it follows certain standards and is actually provided to the researcher in the form of data products or syntheses, which then can really be mined as long as you have individual data sets that are just stored in the form of individual entities. You can't really do that data mining yet. And just to give you an example, this is a database that I have been involved with over many years. It's a synthesis of the composition of rocks from the ocean floor. And today, within a couple of minutes, researchers are able to pull out data that they need for a specific question. This particular data set was pulled from 300 different publications within 2 minutes and plotted on a map where you can show sort of correlations with spatial aspects of the data and so on. And that's what really makes the data useful for the researchers. So what does that require? In my view, it requires a domain-driven data curation. And that means with domain-specific knowledge, we have to develop and maintain and promote standards for the data documentation, for provenance documentation, for taxonomies that describe the data properly, and so on. And these guidelines need to be sort of worked on with the community. They need to be brought out to the community, lots of outreach activities, education, training, and so on. But then there also has to be that component of mapping what comes out of a domain to the overall picture of standards and technology developments. So I see a very central role of the domain repositories in that they link up with the science communities with all the things that I just mentioned, but then interact with all these other stakeholders in the research data ecosystem, like funding agencies, the publishers, libraries and long-term archives, or computer scientists, and so on. But what Fiona just mentioned and talked quite a bit about, this accreditation is a problem for many of the domain repositories who live off funding from agencies where the funding is actually time limited. It's sometimes contracts, sometimes just awards that don't really give the persistence of the archive that is required in order to get the accreditation. So I fully agree that a repository needs to have these features of long-term archiving, ensuring persistent access to the data, unique identification of data sets, proper discovery interfaces for the data. But we need to somehow figure out how we can make that happen for all these different repositories, and I will come back to that. I just wanted to give you some brief examples of the data facility that I'm heading, what we're trying to do for investigators in order to advance the access to the data and their utility, really making the data reusable. So this is AIDA. And we do a lot of different activities and actually serving some different domains, including the marine geophysics community, geochemists, geochronology, so those are sort of specific domains within the earth sciences. We operate a repository, work with other long-term archives because we can't ensure otherwise the long-term access to the data. We are registering data sets with DOIs, so they are uniquely identifiable. And we provide a lot of support to researchers, do outreach. We support them with data management activities, with tools for creating data management plans and so on. But we also provide these data products that actually make the data more usable and more useful for future research. We've developed a number of standards with the community, running many workshops out there. We have created, for example, also unique persistent identifiers for samples, so they can be uniquely cited in publications and in data systems. We have established guidelines that are accessible to the community. We provide templates for the data to be submitted so investigators know what they actually have to put in, or we have tools online that create these data sets for submission. We're trying to follow as much these data publication procedures that Fiona also explained already, and having a review process of the data parallel to review of a scientific article, and then linking up through DOI, linking between the data set and the publication, and ultimately ingesting data sets that are appropriate into these syntheses and data products. And you can see here, that's an example of one of our landing pages, how the DOI of the data set links up with the DOI of the primary publication, and even in the meantime with funding awards, so investigators are actually able to produce compliance reports for their awards. We have established links with the publication, so you can see here as an example an article from Earth and Planetary Science Letters and Elsevier Journal, which shows on the side panel a link to the AIDA EarthChem system. When you click on that, you get directly to the data and can see them in the context of other data. This is one of our syntheses. We have also started to integrate these unique identifiers for samples into data tables. They are active links. When you click on them, you get information about the sample, and in the future we'll see all the other data sets available in other articles for that same particular sample. So the problem really gets to be the diversity of data repositories and data communities when you think of domain-specific repositories. They are highly relevant, but how does a publisher interact with that many communities? This is a graph from the EarthCube effort as well, showing how many different individual communities there are, and I've put on the side a few of the bigger data facilities that the National Science Foundation currently supports. So how can we scale current data infrastructure and especially streamline communication and operation that allows for more efficiency and effectiveness and also inclusiveness, because there are many domains that actually don't have any good repositories yet and need to be served as well. So I think there is a sort of move at the moment to consider a layered model that provides common services and discipline-specific services at different layers. And this graph is actually taken from the European Data Infrastructure, UDAT, that is taking this approach to have a common data services foundation that provides persistent storage, identification of data sets, authentication, and so on, workflow, and that would be a layer, I think, where the integration with the publishers can happen. And then you have community-specific support services that ensure that all these things that I've been talking about are actually taken care of, that there are standards for individual communities, that there is a liaison into these different disciplines with some expertise that can help researchers advance with their data management. So what needs to happen increasingly, and Fiona's last slide already showed you a pretty long list of activity or initiatives where people have come together now and tried to align their procedures, their policies, come to common approaches in technologies or in standards for data description and so on. That's, I think, the move that we're seeing: more partnerships, more collaborations, and I've just listed three: the Earth Science Information Partners, the ICSO World Data System that Fiona mentioned already, and the Research Data Alliance. I wanted to mention two new efforts within the earth sciences that could potentially establish models for other communities to bring the domain-specific perspective into this picture. One has come out of the EarthCube activities, is the Council of Data Facilities, where the data facilities have actually met at a workshop and decided that they would like to establish this council in order to have more coordination and collaboration among these different facilities, provide a collective voice towards the funding agencies, for example, try to align their standards and best practices, and also think about shared infrastructure services, that bottom layer that I have been talking about earlier. The other effort is an editors roundtable. I initiated an editors roundtable for geochemistry now 7 years ago, that actually recommended best practices for geochemical data, and we have recently last year extended that across all the earth sciences, basically providing a forum for editors, reviewers, authors, and publishers, data facilities to talk together, to inform each other about what's going on, and take actually some, real practical steps of having a wiki where people can look up what data facility is available for specific data types, what standards do exist for those particular data types, what are the procedures, who do I need to contact, and so on. And we're just at the moment starting the series of regular meetings at major conferences, and I mentioned there, in case anybody of you is going to be there, in 2 weeks, the Goldschmidt Conference in Sacramento. So we're just trying to foster communication, and hopefully that leads to more alignment in practices and policies. So my final takeaway messages that I would like you to remember from this is that domain-specific repositories play a critical role in the research data ecosystem. They can ensure that data remain fitness for long-term reuse. They should clearly be integrated into the scholarly communication process because they can provide editorial processes for data and linking data and interpretations in the published literature. And collaborations and partnerships among the various stakeholders are really required for us to effectively implement relevant components and grow the research data ecosystem. Thank you.